sections P4 and P8. We're going to talk about exponents, some rules of exponents. So you should probably know all the rules that we're going to go over today. And then we're going to talk about solving some basic equations, which again, you should be pretty familiar with. Okay, so rational, exponents, and radicals. So maybe not the most exciting thing we've ever talked about, but it'll be important later. So you should already have seen a number of different kinds of exponents in a previous math class. This is going to be a quick review. So to refresh your memory, spend a minute or two, work in your groups, trying to simplify this expression, and make sure you get it to come out to this answer. Okay, so when you're dealing with exponents, when you have two things in parentheses being multiplied together, you have to raise both of them to the exponent. So to simplify this first expression on the top here, we would have 4 cubed times x to the what? 6th. Yes, raising a power to a power, you multiply the exponents. Good. And then my denominator is going to be 2 to the 7th times x to the 7th. So it's 2 times x. You have to raise both things to the 7th power. All right, and then 3x squared, there's nothing to be done there. And 4x to the 5th, also nothing to be done. Okay, so now I can do my favorite thing in the world, canceling, right? Love it. Okay, so I have 4 cubed here, so I have 3 4s up here, and I have 1 4 down here. So I can cancel one of the 4s. So I can cross that out, change that to a 2. Does that make sense? Okay, because 4 cubed just means 4 times 4 times 4. And then you have a divided by 4, because there's one on the bottom. So 4 times 4 times 4 divided by 4, 2 of the 4s cancel, and you just have 2 4s left on top. Okay, now here I have 6 x's, 8 x's, right? Because this is x times 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 x. So I have a total of 8 x's on top, and I have 12 on the bottom. So when I cancel, how many am I going to have left, and where are they? 4 on the bottom. You got it. So this is going to become 4 squared times 3. 3 is still on the top here. On the bottom, I'm still going to have a 2 to the 7th. And I'm going to have x to the 4th. And then I can see if 4 cubed times 3 over 2 to the 7th simplifies it all. So 4 squared is 16 times 3 is 48. 2 to the 7th is 128. And 8 goes into both 48 and 128. So we can reduce that fraction to 8 over 8x to the 4th. Sorry, 3. So we used a lot of rules when we were doing this. A lot of rules that helped us simplify about exponents. So there's a little summary here, right, of some of the properties that we used. X to the 0. Anything to the 0 is what? Who remembers? 1. Very good. How about x to a negative exponent? How do you deal with a negative exponent? Make it into a fraction. Yeah, you flip it and make the exponent positive. So this would become 1 over x to the positive n. Was that an n? Can't really see it on here. Okay, good. Now, x to the a times x to the b, how do you deal with that? X to the a plus b. Yep. If you ever forget one of these, you can refigure it out really easy. Like, let's pick x cubed times x to the fourth, right? And the question is, shoot, do I multiply those exponents or do I add them? Just remind yourself what it means to be raised to a power. X cubed means x times x times x. And x to the fourth means x times x times x times x. How many x's do I have written down here? 7. This is x to the 7th. So we add them. All right, what if I have x to the a over x to the b? Yep, good. X to the a minus b. Similar argument is over there. If I had x to the 5th over x squared, this means x times x times x times x times x. The denominator means x times x. Do my favorite thing and cancel, and you get x cubed. And 5 minus 3. 5 minus 2 gives you the 3. What if you're raising a power to a power? X to the a raised to the b. You multiply x to the ab. Again, you could figure this out by subbing in a couple numbers and remembering what it means to be an exponent. So let's say I want to do x squared cubed. So if I have x squared cubed and you're asking yourself, oh, do I add those or do I multiply them, right? You say, okay, well, this means x squared cubed means x squared times x squared times x squared, right? X squared times itself 3 times. And each x squared means x times x. So I have a total here of 6 x's, x to the 6. And you go, oh, must be multiply. So you can always refigure out what the rules are if you forget them. No need for memorization. The only thing you have to remember is what it means to be an exponent. Repeated multiplication. Is this starting to be like, oh, yeah, right, I remember that? Okay, good. So it's easy to confuse those two rules. If you're even the least bit unsure, just double check it like we just did. So now we're going to refresh our memories about roots and fractional exponents. So let's see if we can figure these out without a calculator. Square root of 16, 4. Square root of 25 over 81, 5/9. Yep, you just take the square root of both the top and the bottom. The negative square root of 49. This one does not exist. You can't take the square root of a negative, but in this case, they want me to take the square root of 49 and just put a negative in front of it. So this one's -7. DNE is shorthand for does not exist. Yes, you can, but pretend you don't know that yet. Yeah. Okay, here's a quick way you can double check on your calculator. You can just use the square root button, type in 25 over 81, and then hit change your answer to a fraction. So let me pull up my virtual graphing calculator. So yeah, this thing is kind of awesome. All right, so I want to know, I think the square root of 25 over 81 is 5/9. So I'm going to double check by hitting square root 25 over 81. Press enter. It gives me a decimal. I want to know, is that decimal 5/9? Your calculator can change decimals to fractions. It's very handy when you're, especially if you're taking a test and you have to go fast, right? You use the math button. So you press the math button. The first option is arrow fraction, meaning change to a fraction. So you just hit enter, enter, and it gives you the fraction, 5/9. So we know we were right. And then if I want negative square root 49, I get -7. And if I try the square root of -49, it tells me I can't do that. I quit, yeah. So calculator, pretty handy. Okay, so you can also do cube roots and fourth roots and fifth roots and sixth roots. Okay, so with cube roots, we're looking for a number that when you cube it, you get 64. Anything come to mind? 4. Good. How about a number that when you cube it, you get -8? -2. Yep, -2 times -2 times -2 gives you -8. Fourth root of 81, that is a number that when you raise it to the fourth, you get 81. It's actually just 3. It's an interesting question that we'll talk about when we get to inverses. Okay. The definition of a square root and a fourth root is just the positive answer. Okay. When you're solving an equation, you get 2 solutions, but when you're simplifying a square root or a fourth root or a sixth root, you just give the positive. All right, so the fifth root of 32, a number that when you raise it to the fifth, you get 32 would be 2. Very good. Okay, again, you can check these answers on a calculator. So if I want, say, the fourth root of 81, you type in a 4 first. Then you press the math button and you go down to option 5, which is the xth root. And then you type in an 81 and hit enter, and it'll give you a 3. So your calculator can do fourth roots and fifth roots and things like that. All right, you should be able to handle radicals that have variables inside them as well, not just numbers. So let's see, I want to simplify these. The square root of 49 I know is 7. What's the square root of x to the 8th? X to the 4th, yeah. And the square root of y to the 12th? Y to the 6th. And the square root of z to the 30th? Z to the 15th. So why is it that I took half of each of these exponents? Yes, I was looking for something that when you multiply by itself, you get the answer, you get the x to the 8th. And x to the 4th times x to the 4th, add the exponents, you get x to the 8th. Good. All right, now I want to do a cube root. Cube root of 8 is 2, and the cube root of z to the 6th? Z squared. How do you know z squared? Z squared times z squared times z squared. You add the 2's up and you get 6. You can also say 6 divided by that 3 gives you the 2. And 8 divided by the 2, because it's a square root. So you can always take the exponent and divide by the radical. The index, it's called. All right. Do you remember what it means to have a fraction as an exponent, like 16 to the 3/2? Yeah, awesome. This is the square root of 16 cubed, or the square root of 16 cubed. Doesn't matter where you put the exponent. Could go under the radical or outside the radical. They'll come out the same. So you tend to do the one that makes the problem easier without a calculator. So which one is easier, taking the square root of 16 and then cubing, or cubing 16 and then square rooting? Second one's easier if you don't have a calculator, right? Square root of 16 is 4. 4 cubed is 64. 16 cubed is, I don't know, it's way too big. Can't do it. So, but both of them will come out to 64. So remember, x to the a over b means the bth root of x to the a, or the bth root of x all to the a. So a couple ways to remember. The bottom goes before the radical, so the b and the b. Or if you were raised on a farm, you know that roots go in the cellar, right? So b is the root in the bottom of the fraction. Roots go in the cellar. All right. So take a couple minutes in your groups to work on a few of these. See what you can do, simplifying these. This is the homework for class 2. A little bit more from the handout and the WebAssign class 2 homework. Again, it's due Wednesday, so you'll have plenty of time to do it. You'll probably be able to do it without the lecture, but we'll still finish it up on Monday.